Welcome back, everybody. We are going to start fourth quarter with graphing quadratic functions. So let's talk a little bit about the basics. Pause the video for a minute and write down your vocabulary. We're going to start with our function f of x equals x squared. This is our parent function. So I'm going to note that up here. This is our parent function. I'm going to make my xy table first. And I'm going to use -2, -1, 0, 1, and 2 for my x values. To find our y values, we're plugging those into the function. And so -2 squared is +4. -1 squared is +1. 0 squared is 0. 1 squared is 1. And 2 squared, is 4. And so you'll notice that on either side of 0, 0, the numbers are repeating themselves. And this will be the same every time you do the parent function. If I graph this, let's do purple. I have -2, 4, -1, 1, 0, 0 there at the origin, 1, 1, and 2, 4. Could actually make this a little bit bigger. -3 squared is +9, and +3 squared is +9. And so here is my parent function parabola. You want to make sure it does look like it curves down here at the bottom and not a V. It is a U rather than a V. All right, on this right here, this point is our vertex. And so our vertex is at 0, 0. That's the lowest point of the parabola because our parabola is opening up. Our y-intercept is the place where our graph touches the y-axis, and that's at 0, 0. Because our vertex is at the bottom of our graph, it is a minimum value. Our axis of symmetry. Our axis of symmetry, I'm going to erase this here, is a line that we can draw where our graph can fold over onto itself exactly and symmetrical. So that's going to be right here through our vertex. And the equation is always going to be x equals, and then this x value right here is 0. So our axis of symmetry is x equals 0. If we fold on this dotted line that I drew in, our purple parabola here, this +3, 9 here will fold over right there onto the -3, 9. Those points will match exactly. Our domain. Our domain is always going to be -infinity to infinity. We have an arrow on the left and an arrow on the right. Even though they're pointing up, the left arrow is going, the graph is going to the left a little bit. And on the right, that up arrow is still going to the right a little bit. So that's -infinity to infinity. Our range is going to depend on where our vertex is and the direction that our graph opens. Our vertex here is our lowest point, and that y value is 0. And our graph is pointing up, so all those numbers are greater than. So we have y is greater than or equal to 0. And last but not least, it's asking us to mark areas of increasing and decreasing. So this is going to be as you're tracing the graph from left to right, is your graph going up or down? So on the left, if I'm tracing this graph, my marker's going down here. And so this is going to be a decreasing. And then on the right side, my marker is going up again, and so that's going to be increasing. Underneath this table is some blank space, so let's go ahead and put some tips there. Pause for a minute to write these down. So let's see what we can get out of a parabola that is already graphed. I'm going to start with finding my vertex, which in this case is down here. Now it looks like these are going by 2s, the scale on the x-axis. So that makes our vertex at the ordered pair 2, -4. Remember, our axis of symmetry always goes through the vertex of our graph right there, and that will have x is equal to 2. This value and this value should always be the same thing. Our y-intercept, we can see, is right over here at 0, 0. X-intercept is where the graph is touching the x-axis. And so I see it touching the x-axis in these two places here. That's at 0, 0 and 4, 0. Increasing, if I'm tracing my graph, I'm going up on the right side. And that is from the vertex at x is 2 to positive infinity. Decreasing is over here on the left side. Which starts at the arrow for negative infinity and stops at our vertex at 2. Remember, our domain is always negative infinity to infinity. Our range, we have going greater than, because our arrows are pointing up. It's an up-facing parabola, so y is greater than or equal to. Our vertex is down here, and the y value is -4, and so y is greater than or equal to -4. Go ahead, pause the video, and do the U-try number 1. Example 2, graphing, vertical stretches and shrinks. The x squared would be our parent function. So the 3 being different says that this is going to be a vertical stretch or a shrink. We multiply the y values of our table for the stretch or the shrink. So if I start on my xy table, -2, -1, 0, 1, 2, our parent function was 4, 1, 0, 1, 4. So if we multiply those by 3, 4 times 3 is 12, 1 times 3 is 3, 0 times 3 is 0, 1 times 3 is 3, and 4 times 3 is 12. So to plot this, remember we're using the x and then our new y value, so -212, which is off our graph. I'm going to estimate it about there. We have -1, 3, 0, 0, 1, 3, and 2, 12. Again, do your best to try to make sure that this is curvy down here and not a V. Our vertex, remember, is our point, our lowest or highest point, depending on the direction that your parabola opens. Your arrows up here are going up, so our direction of opening is up. That makes this point right here our vertex, which is at 0, 0. The vertex is a minimum because it's the lowest point. Our axis of symmetry is x equals 0, because we have our 0 here in the x part of our vertex. The y-intercept, where our graph is touching the y-axis, is also at 0, 0. What happened to the graph then compared to the parent function? Well, the graph stretched closer to the y-axis. So this is called a vertical stretch. And that is because a is greater than 1. Increasing and decreasing again from left to right. So starting on the left, my marker is going down. So this is decreasing. And on the right, my marker is going up. This is increasing. Our domain, always negative infinity to infinity. And our range, because it's opening up, we have y is greater than or equal to. And the y value of our vertex is 0. One-third x squared. Our parent function, remember, again, is x squared. So 1/3 is how we're changing. We're still multiplying the y value by that 1/3. I'm going to keep my same original 41014 starting xy table. And then we're multiplying the y value by 1/3. So 4 times 1/3 is 4/3. 1 times 1/3 is 1/3. 0 times 1/3 is 0. 1 times 1/3 is 1/3. And 4 times 1/3 is 4/3. So to graph, we have negative 2 4/3. Well, 4/3 is about 1.33. So we're going to estimate it about right there. Negative 1 1/3 is about right there. 0, 0, 1 1/3, and 2 4/3. And so sketching a rough graph, that's what our graph looks like. Our graph is opening up. Our y-intercept, where it's touching the y-axis, is right down here at 0, 0. That's also our vertex. Our vertex is our lowest point, so that is a minimum. Our axis of symmetry is x equals 0. So remember, it goes through the vertex, the x value of that vertex. So what happened to our graph? Well, compared to our parent function that we did on the first page, this graph shrank away from the y-axis. It pushed out that way. And so this is called a vertical shrink, because A is in between 0 and 1. Areas of increasing and decreasing. Again, over here, my marker was moving down to head that way, so that is decreasing. And it's moving up to go this way. That is increasing. Our domain, negative infinity to infinity. Our range, it's opening up, so it's greater than or equal to. And the y value of our vertex is 0. So y is greater than or equal to 0. Our last example for today, we have negative 4 times x squared. X squared, again, remember, is our parent function, so the negative 4 is our transformation. That means that we're multiplying our y value by negative 4. I'm keeping, again, my same starting points, 4, 1, 0, 1, 4. We're multiplying y by negative 4. 4 times negative 4 is negative 16. 1 times negative 4 is negative 4. 0 times negative 4 is 0. Negative 4 and negative 16. Negative 2, negative 16 is way, way, way down here. So I'll estimate it like way down there. Negative 1, negative 4. 0, 0. 1, negative 4. And 2, negative 16. Again, doing your very best to try to make sure that we know that this is a curvy U line, not a V. And there's our graph. Well, our graph is clearly opening down, which makes our vertex at the top, which is a maximum. Our y-intercept is here where touching the y-axis at 0, 0. That is also the value of our vertex. Our axis of symmetry is still x equals 0. That's the x value of our vertex. And even though it flipped upside down, you can see that our graph stretched closer towards the y-axis. And so this flipped and a vertical stretch. Now this flip is actually called an x-axis reflection. Here's our x-axis right here, and it was up here and it flipped underneath it. So it reflected over that x-axis. Increasing and decreasing. On the left side, now my pen is going up to trace this graph from left to right. So we have increasing on the left side, and then our pen is going down on the right side, making that decreasing. Domain, even though they're going down, the arrows at the ends, we're still talking about left and right. Negative infinity to infinity because I have arrows at both ends. And then the range, we have y. It's opening down, so less than or equal to, and the y value of our vertex is 0. So the range would be y is less than or equal to 0. This is where we will stop for today. Thanks so much for joining me. Have a great rest of your night.